All right, for number one, what's the first thing we need to find? Side C, angle A, or angle B? Can't find angle B yet. Normally, you're right. We would find the largest one first when given side, side, side. The problem is, I don't know what C is. So we're gonna do side C, and then we can find an angle. And to find side C, we would use the law of sines or cosines. Cosines. That's okay. And if, to be honest though, if you try both of those things, I think you'll quickly find that you are missing like one piece of information for both of them. And so you'll get the right answer anyway. Right. There's no. Or you'll give up, in which case, then you won't. But if you don't give up, if you then just keep trying and say, well, what if I find a different, what if I find C first, right? And then try to use the law of sines, be like, oh, wait, I'm missing, a sine of A or sine of B to use. And then, all right, law of cosines, you'll get there. All right, so if we plug into this, we'll get 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 37 degrees. Type that into the calculator. Mm-hmm. 6.666 344,593. Or if we round to the, thousandth place, that's a lot of sixes. Okay. Now, do we find the smallest angle first or the largest angle first for side angle side? Or because A is so low in the alphabet, right? It's so small. Largest, side, side, side. And that's when we don't have any angles. We have 3 sides, like side C. Then we find the largest one first because S is so late in the alphabet, right? And to be honest, again, this is another one where if you solve for B first anyway, right? You'll find out when you do the spot check that you have your answers flipped. And then you'll go back and find A first and you'll be okay. So find A first, smallest one first, because this is side angle side angle side. And so since we're given an angle, we got to find the other acute angle first. To do that, we will use the law of sines or the law of cosines. The law of sines will be faster if we set up the sine of A over A equals sine of C over C. And that would mean that A is the sine inverse of side A times the sine 37 degrees over C, which was 6.666. Type that into the calculator and you get a bid. Nope, Mr. Lake. Here we go. Get about that. 46.237. Okay, so normally this is where you would have to go back and say, this is the answer in quadrant 1. What's the answer in quadrant 2? Take 180 minus this, and you'd get, 135 or whatever. But we know A can't be 135 because it's the smaller angle. If there is an obtuse angle in this triangle, it has to be B. That's where we can save ourselves some ambiguity if we do A first, because A has to be acute. You can't have 2 obtuse triangles or angles in a triangle, because if you have two angles bigger than 90 degrees, they'll add up to bigger than 180. And then to find angle B, you now have your choices. You can do law of sines, do law of cosines, but the easiest is, right, I know these three angles have to add up to 180. And so I'm going to take 180 and subtract my other two. And if you do that, you'll get B is about 96.763 degrees. So it turned out the angle B was actually obtuse. If you did that with the law of sines first, it's going to tell you the angle is about, okay, so that's 6 past the vertical. So that's 84. It'll tell you the answer is about 84 degrees when you first did it. And then when you subtract, you'll find out that angle A is bigger than angle B. And when you do your spot check, you'll get in trouble. But if we do the spot check here, you can be confident you did it correct. The biggest angle is opposite the biggest side. The medium angle is opposite the medium side. And the smallest angle is opposite the smallest side. And the picture actually gives you a little hint on this one that B is going to be obtuse. It shows it's just a little bit 90 degrees. So I actually think this one is to scale. All right, number 51 is a question I think we can get right. And I think we can get it right in under a minute. The only thing you need to do to answer number 51 is tell me, where is tangent negative? Which quadrants? Is tangent negative in quadrant 1? No, none of them are negative in quadrant 1, right? They're all positive in quadrant 1 because X and Y are positive. So then the answer cannot be A, right? Pi over 4 is between these two. Answer can't be A, which means the answer can't be E. Is tangent negative in quadrant 2? Because X is negative, right? We're left of the y-axis, X is negative. A positive divided by a negative is negative. So we know 3 pi over 4 is going to be an answer, which eliminates D. Is tangent negative in quadrant 3? Y over X. Y is negative, X is negative. A negative divided by a negative is positive. So this can't be in here. So if this is pi, it's 3 pi over 2. Or if you think, if it'll help you, I'm getting ahead of myself. 3 pi over 2. Or if you help you, 6 pi over 4. Right, those are the same number. 5 pi over 4 is between those two. So it can't be that. Which means it couldn't be D. Again, you get that confirmation. Couldn't be E, you get that confirmation. All that's left then is C, which should make sense because in quadrant 4, tangent would be negative. Y is negative, but X is positive, right? And a negative divided by a positive is negative. So the answer is C. Okay. As a reminder, remember, all are positive here. The only ones that's positive here are cosine and secant. The only ones positive here are tangent, or sorry, not cosine secant. That's Y. Sine and cosecant. Tangent and cotangent are the only ones positive in 3, and then cosine and secant are the only ones positive in 4. And there's an acronym to do this. All smart cookies take care of cotton socks. That's not it. There's some acronym with it. I don't remember what it is. But anyhow. Oh, actually, I do remember what it is. Well, you just use the first one. A, S, T, C. All students take calculus. Or all, there's another one. I don't remember. All students take calculus is the one I remember. All right, questions on 51? In first hour, they wanted to do a review of how to memorize the unit circle. You all interested in that? Do you want to do that? They just asked it spontaneously. Sure, okay, let me show you a trick. I don't know if I've shown this to you before or not, but if I haven't, you should break your pencil.
Yeah.
All right, here's your unit circle. All you need to do to memorize your unit circle is to remember your 1, 2, 3s. Okay, those are your Y values. So here, 1, our first 3 angles. The Y values of these are going to ascend in 1, 2, 3 as our Y values get bigger. So it's going to be blank a half, blank square root of 2 over 2, and blank square root of 3 over 2. If you can remember just this, I think you can fill in everything else. Because if your Y values ascend 1, 2, 3, you know the X values are just the other corresponding one, right? So the X values will descend 1, 2, 3, or they'll just match in their little pairs here. Right, so 1/2 always matches with square root of 3, square root of 2 always matches with itself. Our angles start at pi over 6, pi over 4, pi over 3. Okay, but all you need to memorize to get this unit circle memorized is the Y values 1, 2, 3. Then remember the X values pair. You do have to remember these angles. Pi over 6 is the smallest, pi over 4, and then pi over 3. And then from that, you can build the rest of your unit circle. To get these angles over here, right, we're just going to flip these over the y-axis. So our x values will be the same. They're just going to be negative. So then we get negative square root of 3 over 2 half. Negative square root of 2 over 2. Negative a half square root of 3 over 2. And then to get your angles here, you can just take pi and subtract these angles, or take pi over 2 and add these angles. I think it's easier to take pi and subtract. So like 1 pi minus pi over 6 would be 5 pi's over 6. 1 pi minus pi over 4 would be 3 pi over 4. 1 pi minus a third would be 2/3. And then you probably got the trick by now, but to get my answers down here, I just take my answers above, right, and flip them over the x-axis. So all the y values will be the same. They're just going to be negative. So then this becomes negative square roots of 3, 2 minus a half, negative square roots of 2 over 2, negative square roots of 2 over 2, negative a half, negative square root of 3 over 2. And to get the radian angles that go with it, just again, take your 3 angles and add them to pi. So pi plus a 1/6 is 7 pi over 6. Pi plus a 1/4 would be 5 pi over 4. pi plus a third would be 4 pi over 3. Sure. 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 Do. Again, take your answers, change the y values to negative, flip it over the x-axis. Again, it's probably easier to think of this as 2 pi, and you're going to take away each of these angles. 2 pi minus pi over 6 is 11 pi over 6. 2 pi minus a quarter would be what? That'd be 4 pi over 4. No, 8 pi over 4 minus pi over 4 would be 7 pi over 4. Pi over 2 pi minus a third would be 5 pi over, or sorry. No, that's not what I want. There we go. Undo. That's how we have to erase. All right. So that'd be 2 pi. If I need a common denominator, that'd be 6 pi over 3 minus 1 would be 5 pi over 3. This is 3 pi over 2. And, you know, if you need your points here, I suppose you could write those in too. There you go. And all of this can just be built if you remember your y values. 1, 2, 3. And the angles that go with it, a sixth, a fourth, a third. All right, yay, good review. Questions? Okay. All right. Oh, we're gonna do vectors today. Vectors are pretty easy, but there's a lot about vectors. It's like a very foundational thing that you're gonna work with, that you could do a lot of math with. And because of that, there's a lot of like definition stuff that go into this. So this lesson's gonna take today and tomorrow, if not also Wednesday. We'll see. First thing we're going to talk about to introduce you to vectors is the idea of a directed line segment. A directed line segment has an initial point and a terminal point. It's denoted with this arrow over it telling you which is the initial to the terminal. So I'm going from P to Q. That's kind of what that arrow is telling you. It's sometimes denoted as a half arrow, like in the picture here. But it's basically the notation for array. You're starting at P and going to Q. But it differs from array in that we don't continue on past Q, we stop at Q. Its magnitude is really important, that you're going to be asked a lot about. That's the same thing as its length. And it's denoted by either of these two. I'll tell you, the book uses the second one. To find its magnitude, though, you just use the distance formula. Which if you have memorized, you don't need to write down, but if not, it's just like it's your problem solved for the Pythagorean theorem, right? It's like make a little right triangle here. This distance would be x2 minus x1. This one will be y2 minus y1. And then we're just going to do that squared plus that squared gives me the hypotenuse squared. Okay, you can just write it down and memorize it. That's not too bad. The other thing you have to do a lot of is because these line segments connect 2 points, we can tell the direction of our line segment by using the slope formula, where slope is easy and fun. Just remember it's rise over run, or the difference in your y values over the difference in your x values. So as you can see, it's kind of a lot, but the stuff that you're using, distance formula and slope formula, is stuff that you got in Algebra 1. Though actually, I'm being told now, maybe you didn't get an Algebra 1. Maybe you got it in geometry. Or possibly, no, you would have gotten it in geometry. You had a full geometry year. All right, questions about this? Anybody need more time to write? All right, so that's a directed line segment. A vector, which is what we're going to care a lot about, is has a magnitude and direction. Really, that's all you need on this slide, to be honest. A vector has both magnitude and direction. The rest of this stuff is just like FYI. So every directed line segment that has the same length and is going in the same direction, all of those, the set of them, can be represented by just a single vector V, where V has the same length and same slope as those directed line segments. A vector is sometimes also denoted with other letters like U and W generally are the most common ones. And they're usually bolded like they are here. So a vector, again, is just a mathematical object that has both magnitude and direction and can represent any line segment that has those same quantities. Yay? Right, so now let's start getting to like how you're actually going to use this stuff. So for example, a common thing then to do with vectors is to show that two vectors are equal. So I have a vector V here from 1, 2 to 4, 4, and a vector U here from 0, 0 to 3, 2. What I need you to do is tell me what is the magnitude of V using the distance formula. What is the slope of V using your slope formula? And then repeat that for U. Tell me the distance for U and the slope of U. I will tell you to keep things consistent and save you some work. Your initial point here will be your X sub 1 and Y sub 1. And your terminal point will be X sub 2, Y sub 2. To be honest, that really doesn't matter algebraically. You'll get the same answer, but graphically, and I don't know how your physics teacher will teach you about that, it might matter which one you call which and which. So I'll give you 3 minutes. Take these 4 numbers, plug them in the distance formula. Take these 4 numbers, plug them in the slope. Take the other 4 numbers, plug in distance formula. Other 4 numbers, plug in the slope. Okay. So I'll go ahead and do the first one for us. So you should, if you plug this into the distance formula, have 4 minus 1 squared plus 4 minus 2 squared, which is 3 squared plus 2 squared, which is 9 plus 4, which is the square root of 13. And just leave your answer like that for the homework. If you typed it into the calculator at the start, once you had this, that's fine. I mean, your answer is correct and everything, but I'm pretty sure most of the ones on the homework are want it in terms of a radical. They don't want a rounded decimal. So leave that as the square root of 13. And then for slope, you should have gotten 4 minus 2 over 4 minus 1, which is 2 over 3. And if you do the second one, same thing. You should get 3 minus 0 squared plus 2 minus 0 squared, which is 9 plus 4, which is 3. And 2 minus 0 over 3 minus 0 is 2/3. Yay. Okay. Any questions of this? Or anybody need more time to write? And let's do the component form. So this is where the class, I think, starts to differ from what you'll do in physics. For us, the easiest form to use for a vector for most of our math is actually to use its component form, which is denoted here, or simply, the idea here is I can rewrite my vector as the change in my x values, right? Q1 minus P1 and the change in y. So if you just want to write this, it's probably fine. Any vector can be written as the two components, the change in x and the change in y. Note that this symbol here is not, it's very similar to a greater than or equal than sign, it's just wider. Then it's not as sharp as a greater than or equal than sign. If you use this form, your math gets pretty simplified because this then simplifies to just this. Or again, it'll simplify to just the square root of the change in x squared plus the change in y squared. And your slope would again just be the two components being divided, change in y over the change in x. In terms of vocab, you should include this. If your magnitude of your vector is ever equal to 1, that means your vector is a unit vector. And if the magnitude is 0, that means you have a 0 vector. Those will be important for some of the work that we'll do tomorrow. In physics, I'm pretty sure all the vectors they give you are always in terms of their length and their angle. So it'd be like a ball is kicked, at a 30-degree angle with this initial force or this initial velocity or whatever given they try to give you. And we'll use some of that form later, but I'll tell you, component form, just the change in x over the change in y, is the bee's knees. It's the easiest one to use. Anybody need more time on this one? Do you think it would help? I don't have anything on those walls. I used to have stuff on those walls. But do you think if I could take my really bad Bob Ross paintings that I'm doing and just put those up there? People would appreciate that? Okay. It's canvas, so I don't know exactly how I would hang it, but what? Oh, yeah, that's a good idea. I was gonna tell somebody to like, if they could drill some nails into that, whatever. But yeah, that's a better idea. That'd be easy. All right, two vectors. Oh, a little note that I couldn't fit on the last slide, but I'll fit onto this one. Of course, I think you probably assumed this was true, but if U has a change in X and a change in Y, which are the same values as another vector V, then U and V are equal to each other. Right, if they have their change in X and change in Y are the same, that means their magnitude and direction will be the same too. It'd be impossible for them not to. So I believe then we're going to finish today with this slide, this last example. All right, so you can do most of the work you need to with vectors if you can convert it to component form first. So let's say we have a vector that goes from 4, -7 to -1, 5. I can convert it to component form by simply finding the change in X, which would be X2 minus X1, or -1 minus 4. Which is -5. Find the change in Y, same idea. Difference between your Y values are 5 minus -7. Or 12. So then I can say V is -5, 12. And then if I want to find the magnitude of V, it's really easy. The magnitude of V is the square root of -5 squared plus 12 squared. Or 25 plus 144, which is 169, which is 13. And then the slope of V is super easy. It's just 12 over -5. Just changing Y over changing X. Magnitude, all it does is really save you one line. But slope saves you a lot of time. And to be honest, I am showing a bit more work here than I would expect you to show. If you were doing this and you just said the change in X is -5, change in Y is 12, which means the magnitude is, this, which is 13, this, like, I'm doing a little bit more steps in between than you would really need to do for your homework, quiz, or test. But yay. All right, well, that's how far first hour got, so we'll end there. Yeah. The homework again is not due till Wednesday. And that, again, that might even get pushed back to Thursday. We'll see, because this lesson is pretty big.